Hi everybody, welcome back. So today's topic is all about classification of electrochemical cell. In the last class we focused about basic terminology and the concepts of electrochemistry, and today I'm going to talk about the classification of an electrochemical cell. First of all, I would like to recap the previous topic. We all know that what is electrode potential, and what is anode, what is cathode, and what is the type of chemical reactions which are taking place in the respective anode and cathode compartment. So when you take an electrochemical cell, the anode is always negative and cathode is always going to be a positive one, right? And the anodic reaction is always oxidation and cathodic reaction is always going to be a reduction one. Now oxidation is nothing but a removal of electrons, a removal of valence electron from the particular metal ion, and reduction is nothing but gain of electron by the electron diffusion species. That's called reduction reaction. And redox is nothing but when these two reactions are happen together in a particular electrochemical system. That's called a redox system. Alright, now I am going to talk about the classification of an electrochemical cell. Electrochemical cell. So basically, based on the type of chemical reactions which are taking place and the cell output, the electrochemical cells are furtherly classified into the following four categories. The first one is going to be voltaic cell. Voltaic cell. And the second cell is going to be electrolytic cell. Electrolytic. And the third category is going to be concentration cell, and the fourth one is called fuel cell. Alright, so these four are the classification of electrochemical cell. Now the voltaic cell is otherwise called as galvanic cell. And electrolytic cell is the best representative example for the electrochemical cell is electrolysis process. Electrolysis process is the best example. Say for example, we can take copper coating is the best example for electrolytic process. Alright, now the concentration cell are furtherly divided into two major class, that is based on the concentration of electrolyte and based on the nature of electrodes. Accordingly, they are called as electrolyte concentration cell, and another one is going to be electrode concentration cell. Alright, and fuel cell is nothing but it's a kind of cell. This also comes under electrochemical cell, in which chemical energy is converted into electrical energy, whereas you are not going to give electrolyte for oxidation reduction process, whereas here we are going to supply fuel and oxygen. That's kind of oxidizing agent, oxygen as a source for electron source. Alright, now I am going to classify, I am going to give the examples and the type of reactions occurs in each and every type of cells. Alright, we all know that in an electrochemical cell, the two galvanic cell, the redox reaction is responsible for the production of EMF. And how it can be constructed, how the cells can be constructed. Basically, if we want to construct a kind of voltaic cell, is supposed to have two number of electrode and two number of electrolyte. Let's say Daniel cell. Daniel cell is the best representative example for voltaic cell. For the construction of Daniel cell, I supposed to take copper rod and copper sulfate solution, and zinc rod and zinc sulfate solution in the electrode and electrolyte compartment, right? Alright, now according to the UPSC principle, the anode must be kept at your left hand side and the cathode must be kept at your right hand side. Once you place like this, so we all know that this is a kind of op cell, this is kind of another op cell. If these two op cells are connected together with the help of an electrical wire through one potentiometer, so the potentiometer will tell us how much amount of electricity is being produced during the redox reaction. Alright, after connecting this process, we are supposed to do one more connection also, that's called salt bridge. So salt bridge will help us to reduce the liquid junction potential, and normally this salt bridge will be filled with the common anion which is available in both the electrolyte compartment. Alright, now once we complete the cell connecting process, now this cell will try to operate in the forward reaction. So here energy is released, and also it's a kind of a spontaneous process, which means This is anode right now, this is cathode. As I mentioned earlier, anode sign is always going to be a negative one and cathode sign is always going to be a positive one in an electrochemical cell. Alright, now the anodic reaction is going to be oxidation. In the anode compartment I kept zinc rod, and the cathode I kept copper, and the corresponding electrolyte is going to be copper sulfate, and the corresponding electrolyte over here in the anode compartment is going to be zinc sulfate. Alright, now at anode, zinc will undergo oxidation process. So which means we are going, so all the metals consist of zinc atoms. The zinc metal consists of zinc atoms, and these atoms are bounded together with the help of zinc valence electrons. Now we are going to remove valence electron from the particular zinc atom. Now I am going to take one zinc atom and I am going to remove 2 electrons from the zinc atom. So zinc will get oxidized. Okay, this is called oxidation. Alright, once oxidation is initiated, the released electron will flow in this direction and from anode to cathode. So this is the movement of electron from, and direction of flow from electron flow from anode to cathode compartment. At cathode reduction process will take place. Now the copper sulfate or electron deficient copper cation Cu2 plus. So when you put copper in the water, it will become Cu2 plus and SO4 minus. Now the Cu2 plus will try to get 2 electrons from the anodic compartment and get reduced, and it forms pure copper. So the copper will be deposited on the surface of this copper rod. So this is called deposition of copper atom on the surface of copper rod. So during this process, the copper sulfate concentration decreases considerably. Meanwhile, the weight of zinc metal is also decreases, whereas the number of zinc atoms in the solution is getting increased because considerable number of zinc ion is entering into the solution compartment, and the overall reaction is called as redox reactions. So which means Cu2 plus Zn gives Zn2 plus Cu. So this reaction is called as redox reaction, which is responsible for the production of EMF in an electrochemical cell. So during the production of EMF, there will be a decrease in the free energy of the system. So whenever any chemical reaction is taking place, right, the 3 type of thermodynamic parameters, namely G gives free energy, G stands for energy, free energy, and H stands for enthalpy, that is heat of change of the system, and S stands for entropy. Alright, so all these 3 parameters will get changed during this kind of spontaneous process. And what type of change will happen in the Gibbs free energy system, because this Gibbs free energy is related to the production of EMF. Now definitely there will be a change. So delta G is nothing but Gibbs free energy. Delta indicates change in the free energy. What type of change will take place? The 2 negative changes. Free energy will decrease. So the decrease in the free energy of the system leading to production of EMF, NFE, right? So N is nothing but number of electrons transferred from anode to cathode compartment, and F is nothing but Faraday. 1 Faraday is equal to 96,500 coulomb, and E is nothing but electrode potential or EMF of the particular system. So this is the information about the galvanic or voltaic cell. So this is a kind of electrochemical cell. In galvanic cell, the redox reaction is responsible for the production of EMF in the particular system. Alright, this is one type of cell which comes under electrochemical system. Alright, and the second system is going to be electrolytic cell. So in the case of electrolytic cell, we doesn't need 2 number of electrolyte or electrode. It requires only 1 electrolyte and 2 number of electrodes. In fact, for the construction of electrolytic cell, we need 2 number of electrode, but it requires only 1 number of electrolyte. So this is going to be electrolyte, and here I am going to place 2 number of electrodes. Okay, so now we can take copper deposition, that is called copper plating. Copper plating is the best example for this case. Now this is going to be a kind of iron rod. We can do iron rod, and this can be a copper rod, or we can use a graphite rod also. In the maybe a copper or it may be a graphite rod, inert rod. And after keeping like this, we have to connect this electrode with external source of EMF. So this is a cathode, this is going to be a anode, positive rod. Now the metal to be coated has to be kept as a cathode, and the metal to be coated is placed as anode in the electrochemical system. All right. Now, so initially we took electrolyte, that took copper sulfate in a beaker, and after that I have inserted two number of metal rod. One is going to be iron rod and one is going to be copper rod. And after this, the iron rod is connected to the negative terminal of the battery, and the copper rod is connected to the positive terminal of the battery. Now I am going to pass a considerable amount of electricity to this system, to this electrolytic cell. Now what happens once electricity is passed on this? Now electrolysis will take place. Now it is available in the form of Cu2 plus and SO4 2 minus. Now this is a negative electrode, so it will try to attract all the positive ions. So the positive ions are always called as cation. So the cathode attracts cation. As a result, it will go over here and it gets the energy, that is electrical energy, that is electrons, and get reduced, and it will be deposited on the surface of this metal rod, that is iron rod. Okay, so therefore copper deposition will be taking place in the cathode compartment. So cation migrates towards cathode, so this is going to be cathode. Now when you pass this during the same process itself, there is a positive electrode, so the positive electrode attracts negative ions, so the negative ions are always called as anions. So the negative electrode, that is anode, attracts anions. So all the anions will migrate or approach this positive electrode. So this is called electrolytic system. But here you should be very clear. So when you look at this voltaic cell and electrolytic cell, here in the case of voltaic cell, the anode sign is always going to be negative. Here the anode sign is always going to be a positive one. Here the cathode sign is always going to be a positive one. Here the cathode sign is always going to be a negative one. And here the chemical energy is utilized to produce electrical energy. Here the chemical reactions is bring back with the help of electrical energy. So there is a major difference between voltaic and electrolytic system. And here for the construction of galvanic cell, we need two number of electrolyte, and here it requires only one number of electrolyte. And in voltaic cell it requires two number of electrode, but in electrolytic system it requires only of course this two number of electrodes, but it may be non-identical electrodes. And one more information about this, during this process you can keep, as I mentioned earlier, you can use copper as anode, or if we want to bring down the operating cost, we can go for even graphite also. So if you use copper, what happens, say for example, let us consider about 50 number of Cu2 plus is transferred from the solution to the cathode compartment. So during this process, the same amount of Cu2 plus will be introduced into the solution compartment from the anode area. As a result, the weight of the copper is keep on decreasing during the electrolytic process. Here, meanwhile, the concentration of the electrolyte, copper sulfate solution, remains unaltered even at the completion of the reaction. So this is one case. And the second case, if you place graphite as anode, there will be a change in the concentration of copper sulfate, because anode is graphite, is highly inert in nature, it do not involve any chemical reactions. So therefore, only the copper ions which are available in the solution compartment, it transfer from solution side to cathode compartment. So this is the information about electrolytic process. All right, and the third one is going to be concentration cell. So as I told you earlier, based on the concentration of electrolyte and based on the nature of electrode, we can able to construct two type of cells. All right, now let me explain what is the kind of reaction which is responsible for the production of EMF. In fact, this is a kind of cell in which chemical energy is produced at the expense of chemical reactions. In fact, now I am going to explain about the process of electrolytic system, electrolyte concentration cell. So for the construction of electrolyte concentration cell, we need two number of electrolyte, but it's a kind of identical electrolyte, but the concentration will be different. So in the container 1 we took the electrolyte, so we can take it as a silver nitrate, silver nitrate system, silver electrode and silver nitrate system we are going to take as a represented example. And in the first compartment I took silver nitrate, and the concentration of silver nitrate is going to be, let us assume there is C1. Okay. And in the second compartment I took again silver nitrate, but the concentration of the silver nitrate is going to be C2, where C2 is greater than C1, which means this is higher concentrated solution, C2 is higher concentration and C1 is going to be a low concentration. Compared to this one, it's a lower concentration. And after that I supposed to immerse two number of identical electrode, identical metal. So now I am going to place a silver metal, right? So I am going to place a silver metal on it, silver metal, and both are in same concentration. Let us say this is M1 and this is M2. M stands for metal. Here M1 is equal to M2. So therefore, for the construction of electrolyte concentration cell, we need two identical electrode and identical electrolyte, but the concentration of electrolyte will be different in nature. Alright, so one will be higher in concentration and another one will be lesser in concentration. And after that, these two metal has to be connected with the help of electrical wire through one potentiometer. So which will the deflection will tells about the quantum of electricity is produced. And after that, we supposed to place one more device called salt bridge, so which is essential for removing the liquid junction potential, and it might be having a common anion. So here common anion is going to be a NO3, because we took silver nitrate over here, and here also we took silver nitrate. So the common anion over here is NO3 minus. So the such solution will be taken over here. So for this we can go for ammonium nitrate, H4NO3, so which is having common NO3 minus. Alright, now this is the complete setup of an electrolytic cell. Now, which is the type of reaction is responsible for the production of EMF? So in the case of voltaic cell, the electrical energy is produced at the expense of chemical reactions. So here such reaction is not responsible. In fact, here transfer of substance, there will be a physical change in the system. Here, as I told you earlier, this higher concentration side and this is the lower electrolyte concentration. Now the higher concentrated solution, that is C2, ions from the C2 will be migrated from cathode compartment to, this is anode. In fact, this is anode, this is cathode, negative electrode, negative positive compartment. I'm sorry, this is negative, this is going to be a positive one. So therefore, there will be physical change in the system. Now concentration, I mean the higher concentrated solution, that is C2, considerable number of ions will be migrated from cathode area to anode area. So during the process, there will be a change in the free energy system, minus delta E is equal to NFE. Okay, so such type of cells are called as electrolytic cell. So I repeat, I'm sorry, such type of reactions or such type of cell systems called as electrolyte concentration cell. So in electrolyte concentration cell, electrical energy arises due to the transfer of substance from higher concentration side to lower concentration side. Alright. So as I told you earlier, so the concentration cell is furtherly classified into electrode also, electrode concentration cell. So here the basic difference is, in electrode concentration cell, we are going to take again identical electrode and identical electrode. So the only difference is going to be concentration of electrode. So we took two electrolytes, same concentrated electrolyte into different beaker, different compartment, and we are going to use two identical electrode but different in composition. This is again, you can take AG, this is AG, represented as M1, this is M2, and this is going to be AG nitrate, silver nitrate, this is also silver nitrate, that is C1, and this is going to be C2. Now C1 is equal to C2, whereas M1 is not equal to M2. The concentration of metal is going to be a different one. So therefore, this type of cell is called as electrode concentration cell. And after constructing this off cell, this is off cell, this is another off cell. These two cells has to be connected with each other with the help of potentiometer. And also we are supposed to have one more device called salt bridge, which is having common anion. Now cell will start to operate. Now what happens, due to the transfer of substance, again from the higher concentration side of the electrode to lower concentration of electrode will takes place, that leading to the production of EMF. Even during the process also there will be change in the Gibbs free energy system, so leading to the production of EMF, where N is nothing but the number of electron transferred, F is nothing but Faraday, and E is nothing but Coulomb process. Alright, so fuel cell is also a kind of electrochemical cell in which electric energy is produced due to the expense of chemical reactions. Here we are going to use hydrogen as a fuel. There are number of types are available, like hydrogen oxygen fuel cell and solid oxide fuel cell, molten carbonate fuel cell, MC, molten carbonate, MCF stands for molten carbonate fuel cell, and methane fuel cell. A number of classifications are available. Now I am going to give one example, that is a hydrogen oxygen fuel cell. So for the construction of hydrogen oxygen fuel cell, we need two number of porous nature electrodes, the two graphite rod, inert electrode, that's a graphite rod, and this is the typical construction process. Alright, now I am going to use two electrode, the two inert and porous in nature. For this we are going to have graphite rod over here, and in between we suppose to have a kind of ion permeable membrane, so it will allow the passage of ions. So this is having ion permeable membrane over here, so it will permit the movement of ions over here. And after this I am going to use KOH as an electrolyte, KOH, and this is anode, negative electrode, this is going to be a cathode, positive electrode, and these two has to be connected. Now I am going to pass hydrogen as a fuel, and here I am going to use oxygen, O2, as oxidizing agent. Now this is a complete setup of hydrogen oxygen fuel cell. Once hydrogen is passed through this compartment, through this electrolyte, now what happens, it will start to undergo various chemical reactions. Fuel cell at anode, oxidation will take place. 2 moles of hydrogen will react with this OH minus, which is available in the electrolyte compartment. So here we have KOH as electrolyte, so that will react with this hydrogen molecule, and it will release 2H2O plus 4 number of electrons. So in fact 4 number of water molecule will be produced along with 4 number of electrons. So these 4 electrons will be consumed at H2O, cathode compartment. So cathode reduction will take place. So here electron will be consumed by the oxygen molecule. As a result, it will try to form 4 number of OH minus again. Okay, so this produced OH minus will be utilized in the anode compartment, and the released electron will be consumed by the cathode compartment. So the overall reaction is going to be 2H2O, this is 2H2 plus O2 gives 2H2O plus energy. So the energy is going to be a electrical energy. So basically in the combustion system, when you use fuel, it will release the energy in the form of heat, whereas in the case of fuel cell there won't be such kind of combustion will take place. Instead it will involve transfer of electron from one system to another system. That too, here transfer of electrons will take place from fuel to oxidizer. Now the oxidizer will get reduced. As a result, now what happens, so this is the overall reaction, fuel plus oxygen gives rise to energy plus oxidized product. So this is the operation of a kind of fuel cell. So all the four systems comes under electrochemical cells. So now I just want to summarize the type of reactions and output and the usage of these kind of cells. So basically the electrochemical cell furtherly divided into 4 classes. One is going to be a voltaic cell, VC stands for voltaic cell, and another one is electrolytic cell, ELC stands for electrolytic cell, and the third one is going to be concentration cell, CC stands for concentration cell, and the fourth one is going to be fuel cell. Now where these cells are used in the industrial systems. So basically the voltaic cells are found useful in all the primary and the secondary storage systems. Say for example like alkaline battery, where the battery which we are using in our like electronic gadgets like cameras or even watches, electronic watches, and even the secondary storage devices like lead acid battery, lithium battery, NICAD battery. All these systems function under the principle of voltaic cells. So here these cells can operate both forward and reversible reactions. So actually means, or we can say that here both voltaic process as well as electrolytic process will be taking place in the respective anode and cathode compartment. And electrolytic concepts, electrolytic cells are found highly useful in the electroplating technique. Electroplating. So this is the one of the important thing in the industrial sector. It is highly useful to coat less reactive metal on highly reactive metal. Say for example, we can say galvanizing, tinning, and copper coating. Galvanizing is nothing but deposition of zinc over iron, and tinning is nothing but deposition of tin metal, SN, tin metal over highly reactive metal, and the other one is copper coating. Even in fact we can say AG, silver coating. Even we can say AU, copper, I'm sorry, that is gold coating. So these kind of coating process can be the deposition of these metal can be done on highly reactive metal with the help of this electrolysis process. All right. And another one is concentration cells. So these cells are highly useful in the energy storage systems. And another one is fuel cell. So this concept is highly useful in the space vehicles. So this in space vehicle the fuel cell is used as a power source. So and the beauty of the cell is even 250 grams of cell is sufficient to produce the electricity for the period of 15 days. So even such small cell can able to produce or satisfy our energy requirement over a period of long time, and this 250 cell can able to produce about 0.8 to 1 voltage till the death of the cell. So that's all about the conclusion and summary of electrochemical cell. Okay, dear friends, today we focused about classification of electrochemical cell. So these cells are classified based on the type of chemical reaction occurring on it. Accordingly, they are called as voltaic cell, or we can say galvanic cell, and the second one is going to be electrolytic cell, and the third cell is going to be concentration cell. Here the concentration cells are classified in two major class based on the electrode and electrolyte concentration. Accordingly, they are called as electrolyte concentration cell and electrode concentration cell, where we will be using two identical electrode and electrolyte except the particle concentration. And another one is called the fuel cell. Here fuel and oxygen will be used as a raw material. Here in fuel cell, in the normal case combustion reaction will be taking place, whereas in the fuel cell such kind of reaction will not be takes place, whereas it will involve transfer of electron from fuel to oxidizing materials. So that's all about the type of reactions and the process which get involved in the electrochemical system. So thank you for your attention. Thank you very much.